Beautiful. I think. Surely. Yep. Oh! Cuss. Natalie? That's all over the internet, too. Everybody knows you're late. Okay. So, in our haste to print these notes, so just so you guys know, we don't do all this stuff. Some guy, you can see his name's on here, Brian Passwater. They didn't have a book for AP Pre-Cal. And AP Pre-Cal is so different from regular Pre-Cal, we couldn't use an old Pre-Cal book. There is no way anybody would have passed an exam on the AP exam with an old Pre-Cal book. No way. It's, I don't want to say it's completely different, but it is. The language, just everything's just so much different. I like this a whole lot better because, again, it does really tie you into calculus. It is a pre-calculus class. So this guy, Brian Passwater, came up with all these notes, and he helped write the test. So we decided if you're going to help write the test, surely to goodness, we ought to probably use your stuff. So we did. And after 2 years, he has redone some of it, and he didn't redo it until this summer. 1-1 is one of those. So I have 1-1 notes that go somewhat along with those, but yet they add a little bit more. They have more examples, which is better for you guys in the long run. Okay? So that I apologize for. This is the only one we've noticed, and everything's pretty much stayed the same up until then, but it's the very first one that I think it's more of the introduction type stuff, a lot more stuff, again, just to kind of get you familiarized with the topic. Okay? So for that, I apologize. So these are the notes that I'm going to hit. It will hit all of this stuff in your book or in your notebook, but it will have more. Okay with what I'm saying? So however we want to handle that, but I'm going to hand you these. And again, I apologize for them not being able to all be together. But I do think it's advantageous. And again, to kind of keep all this in perspective, we still had a 96% pass rate last year with those notes. So no pressure, but it's got to be better. It's got to be better. And I'm making up 96, but it was 90 something, and it was above 95. I mean, several teachers had 100% per class. So no pressure because I'm not competitive at all. Okay, everybody get one? Okay, so that's why he says that. And if you want to cuss anybody, he actually puts his email right there. Don't do it though. He gets enough stuff. Great guy. Great guy. We met him. And he does all this. He doesn't even ask for anything. The only thing he asks is that we don't take his name off of this stuff. So, okay, whatever. I'll leave it on there. So we'll get through this lesson today. I will give you some homework. Your counterparts, is that what you call them? What are the other pre-cal classes? I sent this summer. This is stuff you need to know. This is like stuff that you should know already. Okay? I'm going to give it to you. I don't care if you do it or not. I'm not taking a grade on it. However, if you don't know how to do something, you probably need to figure it out. Does that kind of make sense what I'm saying? But I almost consider that busy work. If you already know how to do it, why do it? So if you can look at it and say, man, I know how to do that. I know how to do that. I know how to do it. Don't do it. Or I'm not too sure. Do it and check it. I'll post the answers at some point. But 84 questions. Then there's this one I'm going to give you, which is learning the basics of your calculator. I don't care if you do that. Uh-oh. Cuss. Okay. I'm going to give you your homework. This is your homework, but this is 1-1 through 1-3 homework. So you'll see 1-1 down here at the bottom, 1-1, 1-1. You'll see like a blank page, kind of there's something up here, and then you see 1-2. So don't do those unless you want to. I don't care. I'm not going to stop you from working ahead, but that's not required. Okay. And so when you get done with these, this weekend, because it's going to be due Monday morning, okay? Due Monday morning. When you get done with these, you're going to take your cellular device when you're at home, and you're going to take a picture of this somehow, some way, some form, some fashion. And when I mean by take a picture of it, I don't really want a picture. I want you to scan it by using a PDF form. And I put instructions on Google Classroom. If you get confused, there is plenty of learning. If you can't figure it out, just take a picture of it and send a picture. But if you send a picture, it's really hard for me to see it on my computer, just be honest with you. The PDFs come in so nice and clear, and I can zoom out and I can write on them and I can do all kinds of stuff. Pictures, I can't. That kind of, y'all okay with all that stuff? So somehow or another, try to scan it via some type of a scanner. Most people have a phone. Use your phone, and it doesn't matter, Android, iPhone, whatever. Okay, so you're going to scan it all on one file and just upload it to Google Classroom. Okay, upload it to Google Classroom, put it on your drive, and then you can attach it. Again, there's instructions on it. If you get confused, look it up or talk to your buddies. And again, if you have real big issues, don't worry about it. If you can't get it done, just turn it in on Monday. But if you turn it in, then you don't have 1-2 and 1-3. Y'all okay with what all I'm saying? Good? So that's how I run homeworks most of the time. A lot of times the homeworks are going to be online, period. Like we take these worksheets and basically put them on Edulastic. So number one, you would answer it and you could actually check it to see if it's right. I post these answers. So you probably want to try to do it the best that you can and then check the answers, right? You don't want to do it and then check it because you might be able to see it's all for you guys, right? I don't care. I care that you know the material. And so I have to do this part of it for you to get your points. But it's 3 points if you get it done. If you don't get it done, it's 1 point. And if you don't do any of it, it's 0 points. And if you do it late, it's 2 points. Okay with all that stuff, right? Okay, any questions about that? That's yours because you're leaving early. Beautiful. All right. So, like I said, I get to do what I get to do. A blank is a mathematical relationship that maps a set of input values to a set of output values. Each input value is mapped to exactly blank output values. All of this stuff, you know a lot of this stuff. A lot of this is going to be language today. You know this, but it's like saying it the way we need to say it. So the first blank is function. When I get done doing this, I upload it also to Google Classroom. So I'll upload the notes complete. You should have the blank notes. Well, I don't upload the blank notes because you have the blank notes. And then the video. Y'all okay? Function. Y'all have heard of the word function many, many times. We don't say equations a whole lot in this class. We talk about functions. So we just talk about, they're the same thing. Typically I have y equals something. And so that's just a function. Not all equations are functions, right? In order to be a function, you can only have one output for an input. If you have two outputs, two y values for one input, it's no longer a function. You might remember like the vertical line test, right? If you draw a vertical line and it hits it twice because you have a y value and a y value, then it's not a function. So those things we need to recognize. We need to recognize if it is a function or if it's not a function and why, okay? You can't use the vertical line test in this class. You can't. because that doesn't really tell me it's not a function. Why does a vertical line test fail it? Because there's 2 y values for 1 x value. That's why it's not a function. And so that's the language you have to use in this class, okay? Anytime you ask for that. Oh, duh. I haven't even looked at this, so I didn't even know that's what it said. I'll be honest with you, I swear. In previous courses, you may have used the vertical line test to determine if a function is not. However, in AP calculus, we use a statement, each input has exactly 1 output. Or you can't have 2 outputs for 1 input. You can say it that way, right? When explaining why a given relationship is a function. I can't believe it said, he's freaking brilliant. He would say exactly what I said. Later in this course, fun fact, this is new too, I don't know. Later in this course, we'll try to learn why the vertical line test is not a valid explanation for a function in Unit 3. We're going to discover polar functions. So that's Unit 3. Remember, there's 3 major units. There's 4, but we're only doing 3. We're doing parts of these 4s, but you're only tested on the 3. So those are the 3 big ones. We'll do the part of the 4s that you need for calculus. Okay, some of it's for AB and some of it's for BC. Polar functions. So it's that's something completely new to you guys. But a polar function, if you look at it, it doesn't look like it's a function because it fails the vertical line test, but it's still a function. So that's kind of why we can't say because it passes the vertical line test or fails the vertical line test, okay, because of the polars. The set of input values is called the domain. Domain. Hey, come on in. When we leave, make sure you tell me that I need to change your attendance. Okay? Anybody else do that too? Like if you come in late and I've already done attendance, you make sure before you leave that I fix it. And it's represented by I wanted to say X variable, but they also say the independent variable. So they're all interchangeable, okay? That was too short to be an X, I think. Dent. English is not my strong suit. So a couple of mistakes I have is I can't spell. I don't know English. And the bad one is I have dyslexia. And when I say I have it, it's mostly with numbers. Like I'll say 62 and I'll write 26. So whenever that happens, don't laugh. Just go along with it. And it could be the X also, guys. X. X is the one that's doing the explaining. X is the one that's doing the explaining. That's the one that's doing the explaining. That's the one I'm going to input to see what I'm going to get output, okay? That's the range. And I'm guessing for sure that you've heard domain and range before many, many times. You got to know that the domain goes with the X values. You got to know that the range goes with the Y values. And it's really easy for me because my name is Ray. And if I take that part of it out, then the range has to go with the Y's. And so the domain's the only one that's left. But the domains are the X's. Those are the independent. Those are the dependent. Dependent, which are the Y values. Okay, that's the output. That's why it's always Y equals. I don't want to say always Y equals, but that's typically why you see Y equals. Because it's a whole lot easier to get at Y equals than if you have X equals. If you've got X equals, it's hard to see what the output is if you plug in that, because then you got a whole bunch of Y's. And we'll find out about that throughout this year. Okay. This is something that's very, very easy. But again, and you know this, but it's language. It's language. A function, again, we always use the word function, is positive. Okay, it's positive when the graph is above the y-axis. Duh. Because in a number line, right, you got a number. Uh-oh. Can't do that. I got to turn it back to, let's be colored. Let's throw some colors up here, right? Oh, it didn't change. Cuss. Those are the positive Y's. Those are the negative Y's. So when it's up here or up here, that's where the function's positive. And when it's down here, there we go. That's where it's negative. I mean, duh. That's not like, if you're in this class and you don't know that and you're in this class, you're in the wrong class, right? You're in the wrong class. So we call it positive when it's up here. We call it negative when it's down here. And then I mentioned this on, where are we at? Wednesday. Throughout this course, we're going to learn and study concepts utilizing the 4 mathematical representations: graphical, analytical, numerical, and verbal. And you got to know the interchangeable of all those. So you guys are pretty affluent with the equations, which is the analytical part of it, and the graphical part of it. You're pretty familiar with those. I hope that I can give you at least some kind of an equation and you have an idea of what it looks like, right? If I give you just a simple x, hopefully you recognize that that's a line. If I give you an x squared, hopefully you recognize that's a quadratic. It might open up, it might open down, but it does something like that. So you kind of have an idea what it looks like. Then we got to do numerical. Well, the numerical just goes with the tables, and you probably did some tables also. The big one is the verbal, okay? You have to be able to speak it, and not just speak it, but speak it correctly. To be successful in AP Pre-Cal, we need to be able to identify important information from each representation and construct equivalent representations. So if I give you a graph, you should know close to what the equation looks like, maybe not exact, but at least an idea. Same with tables, and then same with verbal, or vice versa. Any one of those 3, or out of those 4, I should say, one out of those 4, you should know the other 3. Okay, that's just a big deal. And the quicker you can grab those concepts, the better off you're going to be. Whoops. Okay. All right. Example, el número uno. Example, el número uno. So AP Pre-Cal has multiple choice, or sometimes it might be multiple guess, because you have no clue what the answer is. So you're going to guess, right? And then it has free response. And pretty much any AP course you ever take has that. It has multiple choice and it has free response. In the multiple choice, guys, there are 4 choices. There are 4 choices. And if you know anything about this course, typically 2 of them are so wrong that there's no way to accept those. And then the other 2 are close. You just got to figure out which one of those 2 is correct. Sometimes it's 3, but most of the time it's 2. Pretty bad. Okay? So this is the first example we're going to see of that. Example number 1, and it's multiple choice, and you can see the 4 choices. Okay? You have this picture up here that looks like some kind of a vase. Who knows what the heck it is? It says like this. So we got to start breaking these down and looking at this, and we got to understand word problems. I know that's a bad word for most mathematical students, but it's not that bad. You just got to, that's what we got to do. The figure shows an empty vase. Well, okay, it's empty. Good. It could have been filled. I don't know. At t equals 0. Typically, that's something like time is 0, but they're just saying t is equal to 0. Water begins pouring into the vase at a constant rate. So picture water coming into this vase at a constant rate. That means whatever you turn the water on, that's where it stayed. Right? You don't turn it harder, you don't turn it softer. It doesn't fluctuate. That's what calculus is for. Until it is full. Which of the following could depict this situation where time in seconds, so that you got to, oh, sorry. Let's go brown. Time, 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 time. Height, 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 height. You always kind of recognize what the heck's going on. Okay, that's why labeling graphs is really, 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 really important. Which of the following could depict this situation where time in seconds is the independent variable, which duh, it's the independent variable because it's the x, it's down there in the bottom. The independent is helping explain the y, and the height of the water is the dependent. So I'm going to fill this thing up, okay? As it fills up, that's the height. Is it going to fill up at a constant rate? No. I mean, water's going in at a constant rate, but there's no way that this level is going to be the same. This level is not going to be the same. So that's a constant rate. This one would be a picture of like maybe just a can, or a cylinder or something that is the same like that, that would be the constant rate. That would fill it at a constant rate because it's just going to fill up the same speed throughout the entire time, right? That one doesn't do that. It first looks like it starts filling up. It's slow at first? No, fast at first because it's together, right? If it was really, really narrow, it would fill up real quick, right? Think of your glasses when you're trying to get water in a glass, right? If you got a water bottle, God, most of y'all's are the same size. There you go, give me that. Give me this little bad boy here, right? A lot taller, right? But this one's going to get to here a whole lot faster than this one's going to get to here. It has to, because this one has wider. It's going to take longer to get there. So the wider it is, the longer it's going to take to fill up, right? Y'all okay? Not necessarily that, but also the height of it, okay? So it starts off fairly fast, but then slows down, but then speeds back up. Starts off fairly fast, slows down, then speeds up. I don't think that's this one. I think that's doing the opposite. I think it's starting off pretty fast, slows down. This one empties because it starts going down. You'll see that, right? That's the height of the water. So that one, man, there ain't no way it's that one. That one, like, you poured it back out. And that's not what we did. So it has to be this one here. And again, a lot of times you can logically deduce which one of the four has to be the right answer. Any questions about that? When you're studying this type of stuff, when you're studying it, you're going to help yourself a whole lot. Is not only if you know why this one's right, but if you know why the other three are wrong. Okay? Knowing why the other three are wrong will help you when you're studying. So when you're looking through AP Classroom, whoo, I got it right. Good, but you're better off knowing why the other three are wrong. Okay? Just kind of keep all that in mind as you guys are going through this course. All right. Graphical behaviors. Again, most of this stuff you know, but we got to start talking pre-cal. Linear, linear, quadratic, quadratic. Positive, negative, opens up, opens down, whatever. All this stuff you know. This is an increasing function. It's increasing function. As the input values increase, as the input values increase, as x is getting bigger, as x is getting bigger, that means I'm going to the right. As x is getting bigger, as the input values increase, the values always increase. The y values increase. The slope is positive. It's a positive slope. It's a positive slope. So it's increasing function. That one's a decreasing function. That one's a decreasing function. Okay? Pretty easy. Positive, negative slope. So it's very, very possible on your test, is the function increasing or is it decreasing? Or we'll make it a little bit harder and we'll just say, where is it increasing? This one's increasing from negative infinity to positive infinity because it has arrows on it. This one's decreasing from negative infinity to positive infinity. So let's look at the third one really quickly. This one does both. It decreases and increases. It decreases first because it's going downhill. And then at some point down here, which we know we're called the vertex, right? Called the vertex. We'll call it the minimum. In this particular one, we'll call it the minimum. It's decreasing. And again, so I'm going to start talking like tangent lines. That may be some of geometry a little bit. A tangent line is a line that hits that exact point and it's a straight line. Well, if I did that, then the slope's negative, right? A tangent line hits that line and then just keeps going, okay? There's that tangent line. It's still negative. It's actually less negative because I'm getting closer and closer to a zero slope or no slope, where at that particular point, this particular point right there, it's not increasing or decreasing. It's stagnant. Just to the left of it, it's decreasing. Just to the right of it, it's increasing. But right at that point, it's not doing anything. It's horizontal. So it decreases from negative infinity to 0, and then increases from 0 to infinity. Whereas the other one is the exact opposite of that. It's increasing and then decreasing. Again, common sense stuff, but we don't really talk about what the slope is. We don't talk about positive or negative. We talk about increasing or decreasing. Okay? And then the last two, they start talking about concavity. And in mathematics, concavity is very, very important. Okay? Concavity is very, very important. This one is concave up. Concave up. Whereas this one is concave down. Okay? Concave up, concave down. Concave up, concave down. This one is concave up the entire time. It's concave up the entire time. It's concave up, down, down. And I don't know how else to explain that other than you just have to start seeing it. Concave up, concave down. This one has no concavity. This one has no concavity. It's linear. So it's not concave up or concave down. Okay with that? Before we move ahead, it's very important we clarify a few things about the notation and the vocabulary we're going to use throughout this entire course. Again, this is probably the biggest thing about it. First, when describing a feature on the graph, we generally write down intervals where the graph displays those features. We will always use the input variable when writing intervals. One of the biggest mistakes is for you to give me y values. We always talk x values because when you read from left to right. We read from left to right. Well, left is x values. Right is x values. We don't read up and down. So we don't read up and down. We always give you x values. So if I tell you the function is increasing from negative infinity to negative or to positive infinity, you have to know that I'm talking about from the left to the right, it's going uphill. It has to be going uphill because I'm reading from left to right. So everything has to be x values. The only time you'll ever even think about giving me y values is if it asks for the range. That's the only time. Every other time you're going to give me x values. First, when describing features of the graphic generated intervals, we will, oh, I already said that. Okay, if I lost anybody yet, I hope not. I hope it's limited like, holy cow, would you hurry up? Don't worry, at some point I'm going to hurry up and you're going to say, woo, slow down. But day one, the figure shows the graph of a piecewise function. They call it a piecewise function. There is no one particular function you can write that does that. That's basically 1, 2, 3 different pieces. It's 3 different pieces. They're all linear. They're all linear. Y'all did a little bit of piecewise functions maybe, I hope. So they're all linear. We could have linear and quadratic, you could have linear, whatever. But you know what? At some point you better not overlap, because if you overlap, you no longer have a function. Okay? The figure shows a piecewise function from 0 to 9. So that's important for you to recognize. Not only is it important to recognize, but it also says equals to, which you can see that on the graph because that's a colored in dot. Okay? That's a colored in dot. So this is the graph from 0 to 9. What does it do before 0? I have no idea. What does it do after 9? I have no idea. But from 0 to 9, I know what this function does. What are all the intervals where where f is increasing? So you also need to recognize this. They're talking about f, they're talking about f, because it's very, very possible that they give you a picture of f and they give you a picture of g. So make sure you recognize which one you're looking at, okay? Again, these are just things you got to be aware of throughout the entire year. So increasing. Well, increasing now we know means what? Going uphill or it's going positive. So I start right there at 0, not -2, not -2, not -2, because that's a y value. 0, we read from left to right. 0 till 3, not 4. I'll get somebody will do that. Somebody will say it's increasing from -2 to 4. Somebody will say that. And I'm going to take my yardstick I better use the other one. Yeah, it's a little bit longer and it has metal on the end of it. I'm going to take my yardstick and chop your head off because you're no good to society. So anytime on a test, if you see that, that means you just did something really, really stupid. And you're no good to society. And y'all know that I'm kidding. But I like doing that just because you're going, oh no. Because it really emphasizes to you like, you don't want to be that guy or that girl. Okay? So don't go from -2 to 4. Somebody's going to, and it's okay. Just don't do it in me. I almost put 4. By the way, there is a whole lot of crap that's said in, I just put 4 again. Three, there's a lot of stuff that's said in this room that should not leave this room. Me talking about chopping your head off should stay in this room. And I'm going to go through the YouTube video and edit that out. I won't, but. Okay. From here, they don't care if you use a parenthesis or a bracket. They don't care. I do. Because to me, right at that point, and we can argue until we're blue in the face, and I argue with teachers all the time, and I argue with everybody. The only people that are right are the ones that agree with me. But right at that point, it's not increasing or decreasing. It's 0. Right at this point, I don't know what the heck it's doing. I mean, it's a point. I'm starting right there. Right when you start, you don't know what it is. So I like to use parentheses. But AP won't care if you use a bracket or parentheses. AP won't care. And you could see it, if it was multiple choice, you could see it both ways. You will not see 0 to 3 with parentheses and 0 to 3 with a bracket. You will not see that. Okay, you're good with all that. Okay, that's interval notation. That's typically the way you see it. You could see it like that. Okay, you could see it like that, and then you could see it like that. You could see it either way. Either way is accepted. If it was a free response question, they don't care. Hit me.
Wouldn't it not be the like greater than or equal to or less than or equal to?
If it's an, again, yeah, no. Yeah. I mean, yeah, we can argue that too. You won't see open circles. You won't see open circles. Let me rephrase it. You'll see them, just not on stuff like this. That's just an argument that people have all the time. Every time I go to a summer workshop and that teacher up there just says, we can argue about it. And I said, no, you can't argue about it. You can be wrong. It's okay. Anyway, that's not the only time it's increasing, right? Where else is it increasing? 7 to 9, not 7 to 3. I prefer interval notation. It's just easier to write. So if it's a free response question, I'm just going to write it like that. Interval notation. That's what that's called. It looks like a point. I don't like that. It looks like a point, 7, 9. I mean, if we went to Algebra 1 and we said it's increasing from 7 to 9, and they're going to go 7, 9. 7, 9 is not even on a graph. What else was I getting ready to say about that? Oh, Always put the smaller number first. Always put the smaller number first. Don't go from 9 to 7. We don't read right to left. Okay, so always put the smaller number first. Yep. Oh, they don't care. They don't care if you put a comma. They don't care if you put a union. Don't put it in. Don't put an and symbol. Don't put an intersection. I like it. I like the union. Y'all had great algebra 2 teachers. I know that. Y'all know what he means, right, by union? Just a U. That looks good. They don't care if it's a comma. They don't care if they put, I don't like and because it can increase here and here. It has to increase here or here. That's an or symbol. The other one's an and symbol. Again, they don't care. It's funny how they're so particular about some things and other things they don't care about. They don't care about brackets or parentheses. They don't really care if you put a U. And yeah, to me, that's kind of important, but that's me. The second thing that needs to be clarified is rate of change. This one you're going to talk about, again, until we're blue in the face. Okay, rate of change, 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 rate of change. We write it so much that on your homework you'll start saying ROC. Don't do it on a test, but ROC. The second thing that needs to be clarified is rate of change. This phrase will utilize repeatedly. Oh, that's what he said. I wasn't lying. And at calc. It's so important that it's very important that we understand this meeting. So essentially, rate of change is nothing more than the slope. Essentially, rate of change is nothing more than the slope. And the rate of change is either increasing or it's decreasing. So this is now starts getting, hold on. Whoa, you just told me about increasing and decreasing. Increasing going uphill and increasing is going downhill. And that's true. But the rate of change can also increase and the rate of change can decrease. For a linear function, the rate of change doesn't change. It's constant. It's increasing at a constant rate. Or it's decreasing at a constant rate. Okay, so linear functions don't have a rate of change. Well, they do, but it's just constant. It's the slope. It's the slope. Anytime we get away from linear, the rate of change changes. Anytime we get away from linear, the rate of change changes. So here we have two functions, okay? We must clarify. Oh, oops, I'm off of it, okay. We must read carefully in this course. Stating that f is increasing is very different than saying the rate of change is increasing. Okay? So that's just something, that's where we're going to mess up sometimes, okay? You'll catch me doing it. You'll catch me doing it. I might miss one of these, not on purpose, but just because I don't read it carefully. Why are you not going up? Oh, because you're slow. Okay, so this is all examples. That's maybe an exponential decay function. Looks like it. I don't know. It doesn't have arrows on it. They get real lazy and they don't put a lot of arrows on stuff, so I really don't know what it does, but they might as well put little points on the end of it. Whatever. F is positive. Okay, F is positive because it's above the x-axis. F is positive because the output values are all positive. The graph is above the x-axis. All the y values are positive. There are no negatives. There's a bunch of ways to say it. Just don't lie. Don't lie. Don't tell me something wrong. i.e., the graph lies above the x-axis. F is decreasing. It's decreasing because the slope is negative. It's going downhill. F is decreasing because as the x values get bigger, the y values get smaller. Well, that's easy. Yeah, but can you write that on a test? Because if you don't say it verbally correctly, you're going to get dinged. It's decreasing. Guess what? No points. So what? Why? Because as x is getting bigger, y is getting smaller. Because the graph is going downhill. Maybe. Probably not full points, but might get you a little something. Okay? Decreasing. And then we also know it's what? Concave up. Concave up. Okay? We know it's concave up the whole time. Well, I say the whole time from I'm going to assume that that's negative 2 to 1, 2, 3, 4, 5. I'm going to assume that that's negative 2 to 5. Okay? And then it says the rate of change is increasing. The rate of change is increasing. And the reason why it's increasing is because it's concave up. Okay? This is where I'm going to start drawing some tangent lines. Y'all with me? Tangent lines. I draw those all the time to help me. If I draw tangent lines, y'all with me? That slope is pretty steep, but it's negative. That one's less steep, so it's less negative. And if it's less negative, that has to mean that it's increasing, because eventually it's getting into 0. And this is the hard one for students to get. Okay? But because it's concave up and it's negative, okay, it's becoming increasing slope. It's an increasing slope. It starts off really, really negative, and then it becomes less negative, which means the negative numbers are getting bigger. So it's starting off pretty big negative, it's increasing because it's getting towards 0. That one's the hard one to understand at first. Again, big negatives make it smaller. Small negatives make it bigger. Okay? This one here, again, guys recognize F and G. Okay, that's very common for them to do. F and G. G is negative because the whole thing's below the x-axis. All the y values are negative. As x is increasing, I don't need to talk about x is increasing. It's just all the y values. Sometimes functions are both positive and negative. Okay, it's positive from here to here. It's negative from here to here. This one has to be negative the whole time that I can tell. That one's positive the whole time that I can tell. What was that other one? Am I still on draw? This one is negative from 0 to 1, but it's positive from 1 to 9. Okay, so sometimes they're a little of both. It's increasing because the slope is going positive. It's going uphill. As x is getting bigger, y is getting bigger. Again, this is a little different, but y values are starting off small and they're getting bigger. And then this is a concave down function. So because it's concave down, it's actually decreasing because this is almost undefined. And I'm becoming closer to 0. So this is a positive slope. These are positive slopes because it's going uphill. As I get to right around here, I'm becoming almost a 1 slope. And then I'm becoming to almost a 0 slope. So it's a decreasing slope. Decreasing rate of change. I said slope. Decreasing rate of change. Okay? The rate of change is decreasing because it's concave down. Beautiful. Woo! We're doing good? We're doing good. Don't let time slip up on you. Man, guys, you're going to see this picture 277 times this year. I'm lying. I'm making that number up, but you're going to see it a ton, okay? So look at this type of function right here. It starts off right here. Again, this is where we're going back to, right? They don't really start with a point, so you don't know if it's an open circle or closed circle or whatever. I always just treat them as closed, but you don't really know. It goes up to here. That looks like a max. We'll call that a max. I don't know what that is, but there's a min because I'm turning and going back uphill. And I got another max and I got another min, okay? Just a beautiful little function. We can ask all kinds of questions about this function. All kinds of questions about it. This is H. They didn't label it. The graph of H is dashed and it's dashed middle line for 2 cycles. Oh, there's the 2 cycles. Y'all see how it kind of repeats itself? It starts here, goes up, goes down, and then it kind of starts over and does the same thing. So my guess is this could be another starting point. I don't know, though. I don't know. But that's 2 cycles. Sometimes they'll just show you 1 cycle. Sometimes they'll show you 3 cycles. 5 points, F, G, J, K, P, are labeled on the graph. No scale is indicated, and no axes are presented, but they kind of are. I mean, it says no scale, but they're still labeled. The T coordinate of F is T1. Now we're starting to get really stupid. So this is T1, T sub 1, and G is T sub 2. And this is important because basically we can ask you like 15 questions from this. So they may say, hey, this is T1 and this is T2. Or this is T1, or I'm sorry, they won't do, they'll do T1 and T2. Who knows what they're going to label what. So you just got to recognize what's going on. It's not that difficult, okay? On the interval from T1 to T2, why the heck they don't just say from F to G, I don't know, but they should have. Well, I guess they're trying to confuse you, but they're not because you guys are freaking brilliant. So I could have said from F to G, and that might help you, I don't know. But they're all interchangeable because T1 is F and T2 is G. Which of the following is true about H? H is positive. Okay, so looky here, this is 0. So this is like 0. So from F to G, H is positive. That's true. H is positive and increasing. Nope, it's going downhill. Nope, it's going downhill. This one says down here, H is negative. H is not negative. H is not negative. I told you 2 of them are pretty obvious right off the bat. So now you only got choice between 2, and we've already narrowed down that one. H is positive because it's above 0. You have to read that. That's kind of tough to see, but it's above 0, and it's decreasing because it's going downhill. On the AP free, yeah. Here's another one. This is a different one. This is different. This is different. Same picture, different numbers. I'm going from K to P. K to P. Recognize this now. Whoop, whoop, whoop. This is 0, -1. So here's the x-axis. I'm sorry, the y-axis. The y-axis is right here, but the x-axis is up here above it. Because that's -1, that's -4, that's -7. So this whole thing is below the x-axis. So H is positive. No. H is positive. No, because the whole thing's below the x-axis. So H is negative and increasing, or H is negative and decreasing. And I'm going which way? Uphill, downhill? Uphill, so we're increasing. Good enough? Again, a lot of terminology. Let me take my time to go through this because it's very, very important. And this is pretty much the only time we're going to get it. Because from then on, I'm just going to assume you know it. You kind of know this already, but again, it's terminology. Terminology. Oh, here it goes. Describe how the rate of change is going from K to P. Concave up, concave down. Concave down, because it's kind of going this way, it's down. This one's up, so it's going down. So because it's going down, the rate of change or the slope is, or the, I guess I shouldn't say the slope. I guess I could say the slope. Right now it's what? Really, really positive, and it's getting closer and closer to 0. So if you can't remember because it's concave down, it's increasing, I'm sorry, decreasing. Concave down, decreasing, down, decreasing. But just put your little pencil up there and just kind of move with it. I'm really, really steep positive, and I'm getting closer to 0. So how's the rate of change decreasing? Concave, whoops, down. Concave down explains it. If you say it like that, it's okay. That's all you need to say. Ooh, look at this one. This one's weird. They're going to give you all kinds of weird functions, okay? We're doing pretty good. The figure shows the graph from 0 to 9, okay, as well as 6 labeled points. Well, they kind of labeled them. They didn't label them, but they put them on a graph. They put them on a grid sheet. Use the graph of K. Again, make sure we're looking at the K function, because on the test, we try to save paper, and I may throw G and F and K all right there together. I don't want a big old function in the question and another big old function. I want the two functions together to save paper. Just kind of be aware of that stuff. Which of the following intervals is K negative, negative, and decreasing? Well, guys, I'm going to do this right off the bat. I'm going to mark off all that stuff because it says negative. So negative, we got to be below the x-axis. We got to be below the x-axis. So I'm not going to put C anywhere. It's not negative, it's C. Okay, I marked that one off really easily. Negative and decreasing. Decreasing means it's going which way? Uphill, downhill, or concave up or concave down? See, y'all see, right? Okay, I'm not talking about the rate of change decreasing. I'm just talking about decreasing. So that means my slope is going downhill. That's going uphill. So it's going downhill from here, but that's not a point. So I'm going downhill from D to E, D. Again, it probably doesn't hurt you to look and see why these other ones are wrong. B is above, so it's not negative. A to B, that's where it's negative, but it's increasing. E to F, it's negative and increasing. Thank goodness they didn't ask me where it's negative and increasing, because I would have had 2 answers, and that would have been uh-oh. And that happened the first year we did this. They said there's 2 right answers. I said, well, you better put them both. It shouldn't happen. It just did. Which of the following statement? Oh, I got to go back up here. Of K, okay? Uh-oh. Woo, I won't be able to do this. Sorry. Got to do that. Oh, now I need it. Okay. Which of the following is true? The rate of change is negative from A to B. That's concave up. So it's starting off like it's 0 and increasing. Yeah, it's getting positive, so it's not negative. The rate of change is negative from B to C. Ooh, that's concave down. Ooh, I like that one. This one is positive from D to E. Uh-oh, that's concave up. What'd I do wrong? It's positive from E to F. Which one's true? Six. Hit me. Huh? Why? Why is it D? Because it's going up? The rate of change is nothing more than the slope. Oh, y'all saw my confusion with that, right? I did all that on purpose. I was talking about the concavity part of it. I don't care about the concavity, right? The rate of change. Boom. Positive, we're good here. Boop, boop. Which of the following, oh, this one's the rate of change also, right? The rate of change is decreasing. Oh, this is the same question? Just different values, right? Y'all good with this one? Go ahead, hit it, hit it, hit it, hit it. Happy, happy, joy, joy. Good, 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 good. We all got what as a group? B, 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 B. I kind of do it that way. That way, if you don't know, you don't answer, but if everybody answers somewhat close. And then the last one is increasing and concave down. I want increasing and concave down. I want it to be increasing and concave down. Increasing and concave down. And that happens where? Which one? Hit me, everybody. What answer? B? I kept hearing you say C, but you were saying B to C, weren't you? I thought I heard a couple other C. It's B is the answer. Okay, we're good. Uh-oh. We're almost done, guys. Hang with me. We went back to a piecewise function. 1, 2, 3 different pieces of linear, so we don't have to worry about concavity on this one. What intervals is f decreasing? I want f decreasing, and you can write this either way, interval notation, or I forget what other notation they call it. Only one I know is interval. Decreasing. Please don't say 2 to 0, right? Don't say 2 to 0. Where is it both negative and decreasing? Go ahead, kid. You're good. Where is it both negative and oh, it said increasing. Whew, good thing it didn't say negative and decreasing, because I would have had to say nowhere. So negative and increasing is from, careful now, guys. Again, this is where, that's the tricky one. I'm telling you, I'll get some knuckleheads put from -2 to 0. It's x values, x values, x values. Left to right, left to right, left to right. So it's going from -5 to -3. We're good? Y'all okay? Here I got another curved one. 2 more, we'll be done. We're good. So we're going from -5 to 5. A lot of times they'll tell you where it's defined at if you have any questions whatsoever. But that's pretty obvious. It's going from -5 to 5. Point A is at -1, 0. And you can see that point right here. Again, they do a lot of this stuff. It kind of is the obvious, but you're supposed to never believe anything you see, right? You guys learned that in geometry. If it looks congruent, it's congruent. No, you have to prove it. Well, they're telling you this stuff, right? Which intervals is G decreasing and concave up? Increasing, decreasing, but that's decreasing and concave down. This is decreasing but concave up. So that's looking at -1, I'm guessing, until we get to a minimum, which if you said 1.1, you're probably okay, but it's probably just 1. Most of these are going to be integers. Don't get that nitpicky about it. I wouldn't count it wrong if you said 1.1. I wouldn't count it wrong if you said 1.2. I would count it wrong if you said -2. I would count it wrong if you said 2. And I would count it wrong if you said 0. You'll good with all that stuff, right? But most time the integers. So just don't think that much about it. That's -1 to 1, right? And guys, again, if you want to write it like this, that's okay. If you want to write it like that, it's okay. You might see it anyway if it's a multiple choice. And then what's the last one say? Which intervals is the rate of change positive and decreasing? So the rate of change is a slope. I want it to be positive. So that means I need that thing to go uphill. So it goes uphill here. Uphill here, not here, not here, uphill here. So there's uphill, positive, but I want the rate of change to decrease. And it's starting off pretty slope, pretty high slope, and it's getting closer and closer to 0. Therefore, the rate of change is decreasing. It's decreasing because it's concave down. Decreasing down. Decreasing down. So from -5 to -3. Was it? It didn't do it the other one, right? Or did it? No, that one's concave up. Okay, so that one's not decreasing. This one's starting off at 0, and it's getting more and more positive. More and more positive, therefore it has to be increasing. Okay? Yes, no, maybe? Good. Happy, happy, joy, joy. took these out already. I think these are all of them. Again, it sounds horrible, right? But it's sections 1, 2, and 3, right? 1, 2, and 3. On Monday, we're going to do 2 and 3. We've kind of already done some of it. I wanted to do 1 and 2 today, but I thought taking my time doing this lesson is probably more advantageous than rushing through it and doing 2 of them. So, because again, so much of this is algebra 2, we'll go fairly quickly at the beginning. There'll be, you don't want that one. I mean, you can, I don't care, but. Did I get you? No, that's the packet there. Did I get everybody? Miss you guys? I got you guys? I got y'all?